Welcome to part 2 of the Elements, Compounds and Mixtures video, and in this video we're going to look at how we turn elements and mixtures of elements into compounds. So let's scroll through. Right, so our first reaction, if you like. Now what we're going to do is, just to form a compound, we're going to take two elements, iron and sulfur, and you can see that sulfur is spelt here. I've pinched this diagram off the internet. It's spelt with an F, and that's actually the international way of spelling sulfur. You might see some people writing using PH instead of the F. I prefer to write PH instead of the F, and that's okay, but internationally we should use the F for sulfur. And you can see underneath it I've put a picture of the mixture of iron and sulfur. And you can see we've got yellow sulfur mixed with the grey iron particles, and it does look like a mixture of the two components. We could easily separate this. We could use a magnet. Iron is magnetic, so we could use we could use a magnet to attract the iron and just leave behind the yellow sulfur. Now, quite often all we need to do to turn an element into a compound is to combine the elements and heat them. And that's all we do here. We take the iron and the sulfur mixture, put it in a test tube, and we heat it. And lo and behold, the iron atoms bond with the sulfur atoms, and what we get is a compound called iron sulfide. So previously we had a mixture of two elements, and now we've got two elements, but now they're bonded to each other. And you can see this is our product. This is iron sulfide, and it looks nothing like the mixture that we had before. And you'll remember that I said, we could actually separate this mixture using a magnet. We put a magnet next to iron sulfide, nothing will happen. Iron sulfide is not magnetic. The iron atoms previously were magnetic here have lost their magnetic powers, if you like. So they're now bonded to the sulfurs, and you can't separate the compound into its two elements very easily at all. You need to do that with a chemical reaction. So it's very, very difficult to separate a compound or break a compound up into its elements, but it's very, very easy to separate a mixture into its components. So that's the first example of turning two elements into a compound, and you might have seen that in the laboratory at school. And let's look at a second reaction, which I'm hoping you'll have also seen. Right, one of my favourite reactions, where we take magnesium and we heat it very strongly in air, and when it is heated in air it reacts with the oxygen which is in the air and forms a compound, magnesium oxide. So we've got two elements on the left. We've got magnesium, and you can see I've got a picture of magnesium ribbon here, and we've got oxygen, and I've not got a picture of oxygen because it's a colourless gas, you can't see it. We heat the two together, and when the reaction is going on we get this bright white light, and the magnesium atoms bond with the oxygen atoms, magnesium atoms bonded with the oxygen atoms, and form a new substance, magnesium oxide. And you can see it looks completely different. Magnesium oxide is a white powder, magnesium is a silver metal, oxygen is a colourless gas, you can't see it, whereas our product, our compound, is a white powder. And the product, like we saw with iron and sulfur and the iron sulfide, the magnesium oxide has completely different properties to its two components. It's not shiny like the magnesium is, it's white. It's not a gas like the oxygen is. In fact, it's got a much, much higher melting point than magnesium metal. So its properties have changed dramatically. it can't be chopped up into magnesium and oxygen very easily at all. We'd need to do a chemical reaction. Whereas my mixture, which was essentially the magnesium surrounded by the air, was easily separatable. Okay, you just pull the magnesium away. So you can see that the properties of compounds are very different to the elements that make them up. So we're about to finish, and we'll finish with a quick quiz on identifying elements, compounds and mixtures. Now, we did this before using diagrams that showed you different types of atoms. We're going to do it now, but just using words or even symbols. Let's see. Okay, no symbols. I'd forgotten that I hadn't put any symbols on here. Never mind, we will carry on. So we have to decide if we've got elements, compounds or mixtures. And it would be really helpful if you have a periodic table in front of you. And you might be thinking, well, why do I need a periodic table? Well, you need a periodic table because that's got all the elements on the table. So if you're thinking if a substance is an element or something else, if it's on the periodic table, it's going to be an element. So, number 1, magnesium. I'm hoping that you know that magnesium, or you can find it on the periodic table, it's got a symbol Mg. And if it's got a symbol there on the periodic table, it is definitely an element. Water. Well, what's water? Well, you might have heard water referred to as H2O. I'm hoping you have. Therefore, it's made of hydrogen bonded to oxygen. The fact we've written the formula out like this shows that there's some bonding going on between the two elements. So we've got two different elements here. We've got hydrogen and oxygen. They're bonded together, so water is a compound. And it's incredibly difficult to split water up into hydrogen and oxygen separately to produce two gases from the water. We need to pass electricity through it, and that's very difficult. Right, magnesium oxide. Well, magnesium is on the periodic table, and so is oxygen. But magnesium oxide as a substance is not on the periodic table. You can see it combines two elements, magnesium and oxygen. And the fact they're written out like this shows you that they're bonded together, magnesium oxide. So they are a compound. Okay, I actually gave them a symbol earlier in the video, MgO, and so I'll label that as compound. Carbon dioxide, you may have heard it referred to as CO2. Now, what that's showing us is we have, again, two different types of atom, carbon atoms and oxygen atoms, and they're bonded together. So carbon dioxide is also a compound. You have to excuse the writing. The thing I'm writing with is it's not very accurate. Right, I'm going to come back to salt water at the end. Let's do iron and sulfur. We saw this earlier in the video. So iron is an element. You should be able to find iron on the periodic table. It's got a symbol of Fe. Sulfur is also an element. It's got a symbol S. You should hopefully be able to find that on the periodic table. And because we've got the presence, or we're stating the presence of two elements, those two things together are a mixture. We've not talked about them bonding, but iron sulfide, that is the compound made up of iron and sulfur atoms. So we've got two different types of atom bonded together, so that is a compound. And I left salt water till last. Now, salt water is made up of salt and water. Unsurprisingly, the salt has dissolved in the water. So water is a compound H2O. And you may know that salt is a compound called sodium chloride. It's a symbol NaCl. And when the salt dissolves in the water, the salt particles just break up. So we've got sodium floating around in sodium floating around, chloride floating around in amongst the water. So what we have there is a mixture. Okay, we've got a mixture of sodium chloride and water. And that concludes this second video on elements, compounds and mixtures.